Hi, let's create a generative percussion which won't require a sequencer, which won't require any samples, and it's going to be sound like some bongo-like stuff and pretty much acoustic sounding. And for this we are going to use the multi-channel workflow that I used in my snare drum patch, but this way we are going to create another kind of sound. And the base of this is going to be a Euclid node, which will generate the rhythm for us. And for this we need a clock, which we will plug into the clock input. And I like to use a variable which, when connected like this, is only reading the clock signal when the transport is on. So if I hit play, it will work. If I stop, the transport will stop, so the Euclid won't output any triggers. I want to make this more human-like, so I want to randomize this trigger output. And yeah, I create a trigger randomizer node. So here we will receive a trigger, send it into a trigger to gate node, and we will output the gate multiplied by the change, like this. And this kind of patch sends out a trigger when the gate goes high. So if we have a note on, so basically this would output the same as the input, but as soon as we subtract the gate signal from 1, then we have the output when this gate goes low. And controlling the gate time on each trigger with a random value, like using a pseudo random node, or use the rather simple random node, and this should be fine. This way we can randomize the trigger output, basically, and crank up the modulation as well. And this way we have a random delay after a trigger happens. And I want to send this into a state variable filter, which is just a 2-pole filter, and create a gain lin using the bandpass output. And this is the very basic setup. I hit play on the transport. And we have a weak signal, but this will change in a moment as soon as we introduce an envelope here, an envelope modulated node, which will have 2 functions. Really just 1 function, and we will use a mixer here as well. We will plug the trigger into the mixer and multiply the output of the envelope by a white noise. So I'm going to use white noise here. It's not necessary, but I like it. Use a short release and plug this in there. And this way we have a sound like this. And now we might want to smooth this noise a bit using a 1-pole low-pass filter, like this. Yeah, I moved this a bit lower, so this way the patch is easier to read. And yeah, this is the basic setup. And this sounds very synthetic and not like an acoustic bongo, but we will work on it. I have prepared in this designer, or in this effect instance, my mixing matrices and the multi-channel stuff. So these are the mixing matrices that I can use. I have 2 times Hadamard, 4 times Hadamard, 8 times Hadamard, and householder from 1 to 8. And these are all just mixing matrices. They, when a signal arrives at 1 input, it appears on all the outputs, but so that the sum of the output signals equals the input. And it's not a simple division, it's a bit more chaotic and more it's like scattering light when you have a light bounce and it scatters in many directions, but the power of each direction depends on the input. And this householder matrix is a kind of matrix that splits the signal into different channels so that the power is equal on the input and the output side, basically. So I take one householder matrix, 4 time delay, 4 time add, 4 time multiplication, and 4 times input and output. And that's all I need at the moment. I have all this here. And I know this multi-channel stuff looks a bit scary, but let's break this down. We will convert to multi-channel. So now I will do this on a single channel, and then you will see what we do. Then we will insert a delay. We will first we will insert an add node, then a delay. Sorry for the confusion. And then we will use a one-pole filter, and then we will use an all-pass filter, which is just going to be a one-pole filter where we subtract the high pass from the low pass. And we will use a multiplication, and we will feed that back into the input, and the output is going to be the addition, the result of the addition. And one more thing that I forgot to insert is that after the delay we will scatter the signals. So this will be 2 multi. We will have a multi-channel add, a multi-channel delay. We will scatter using the mixing matrix. We will have a low pass, an all pass, and a multiplier on the feedback. That's what we are going to do. And for this we have all these nodes here, which are really just multi-channel stuff. The only difference that is not apparent here is this scattering, which is going to be the householder. So let's convert to multi. I select this cone, select the 2 multi node, replace. It's this simple. I choose the add node, and then I choose the add times 4 node, replace. I choose the delay node, choose the delay 4 times node, replace. Choose the scatter, choose the householder node, replace. These we will have to build, but that's not going to be too hard. So I create a designer, create a basic one-pole filter, create an input called I space 1, create an output called O space 1, and I like to put a space 1 here so the numbers will match. And here we go, we have 4 times low pass filter, create one input for the P, and simply patch it to the corresponding input plug. So this is low pass 4 times. We can replace this filter with this. Nice. Let's create AP 4 times, which is just the low pass, the high pass subtracted from the low pass. So I'm gonna move this to the side, create a subtract here, there, and there, and subtract the high pass from the low pass. It's this simple. So this is a 4 times all pass filter, one pole all pass filter, and we can replace that node like this. And yeah, we have a multiplication, replace, and now we have to wire this whole thing up again, so we have all the channels patched. So the first 4 inputs are coming from the converter. This goes, oh, I forgot the from multi, so this waits there, and these 4 go there. Delay, scattering, low pass filter, all pass filter, multiply, back into the add. And as you can see, all we need is the parameters like delay time, damping filter and dispersion. And I can also delete this here. So let's create the delay times. 1, 2, 3, 4. And let's arrange these a bit like this. And let's use a minimum of 1 millisecond up to 20, maybe with a shape of 4 or 3. Yeah, that should be fine. Or maybe even 0.5 millisecond of the minimum delay. Let's select these 3 and the one at last and press R to replace them. Create some random delay values here. Here this is going to be the feedback, which is between 0 and 1, but most of the time it's below 0.9, and we have useful values only on above 0.9, so I will make it so that this way it's on 1, so minimum on 1, maximum on 0, and we'll turn the shape into like this, so it's 1.9. Here we are above 0.9, and this is what we are not going to use that much, so this is a bit more useful this way for these purposes. And then we have 2 filters. This is going to be dampening between 0 and 150. This is going to be dispersion between 0 and 150 in pitch. And yeah, basically we should have something that sounds pretty metallic the way it's set up now. But let's take a listen. And indeed it's metallic. But as soon as we start to mock around with the dampening and the dispersion, the metallic sound will go away, and we will be left with some wood-like or skin-like sound that really is like a bongo. Nice. So this is one sound now. We have something that works, and now we can tweak it a bit. So like change the rhythm to something more interesting. Okay, and now we want to randomize the velocity, and that's pretty simple. We take a pseudo-random node, and yeah, I will also replace this by a pseudo-random node, so that it's the same on each event. And here we will need a cyclic input, so that it repeats together with these. And do the same once again, like this. And this way we can randomize the velocity with a different seed. And we will just multiply this white noise using the output here between 0 and 1. Nice. And let's bypass the cyclic trigger here as well. Oh no, this is the cyclic trigger. Then this needs to be the gate. So this is the T and this is the cyclic. Like this. And here I can enter any seed and I don't hear that this works. Yeah, this should just be this much. Yeah, this is okay. But this does not do anything. Or does it? It does because the trigger is on. And now we have one sound, but here I will insert a custom function that so that we get a bit more of the lower values. And I will also multiply simply the trigger with this, so that the hit is not always on maximum. Now we are getting there. And after this step, it really just needs to be duplicated. And now we have two patches doing the same. So we change this pattern. We change this pattern. Copy the node. Paste there. Change the pattern and change the sound. Let's create a third one. And you get the idea. This is basically a bongo orchestra now with 3 elements, and we can always add more change the rhythm. Now it sounds like kind of a tabla. And by grouping these and let's delete this, create a reverb. We can put it into some space and make the thing more acoustic. But anyways, you get the idea. So this is my bongo machine that we quickly built, and there's lots of possibilities that you can discover and make it sound better, make it sound completely different, make it sound more synthetic, make it sound more acoustic. You can play around with automating different parameters, randomizing stuff based on different triggers, and you can optimize this patch, but these will be shared by me on our Discord as soon as I know which version I did this in, and maybe it will be shared later a bit, like in a week or 2 weeks, but I will share this patch for sure. But until then you can build this, because this part of the patch can be downloaded from our Discord channel, so you can have all these except the filter and the all-pass filter, but we did build it in no time, this currently, and all the rest is available in the latest beta version, so this should be really something that you can build for yourself if you're using Alpha Forever. And yeah, that's it for today. Thanks for watching. Bye bye.